This video explains mole conversions. Moles are really useful in chemistry because they help us measure very large amounts of very tiny things. If you have a mole, it's kind of like having a dozen of something. A mole stands for a number. A dozen stands for 12. Mole stands for 6.02 times 10 to the 23rd. It's a whole lot. A mole of rabbits would be that many rabbits. A mole of markers would be that many markers. It's also sometimes called Avogadro's number. So you may hear that a mole is equal to Avogadro's number. Well, that's 6.02 times 10 to the 23rd. Over here I have a little, kind of like a little flow chart that helps you see what you can relate the mole to. We can use moles to get to mass. We can use moles to get to volume. And we can use moles to get to particles. If we're doing particles, it's basically counting. It's telling how many of something. And to give you a couple of ideas over here of what this might look like, if I have a chunk of iron, and I have a little cube of iron here, what's inside the iron is nothing but iron atoms. Just atom after atom after atom after atom. Iron is an element, so the particle that would make up the chunk of iron would be called atoms. The particle that would make up, if I had some iron oxide, what that is it's not just atoms. It's going to be an iron and an oxygen attached together. So if I had a bunch of it, then I would have, several pieces of iron, and I would have several pieces of oxygen, and they'd be attached together in little units. This is one particle of iron oxide is one purple and one black. Well, that's not called an atom. It's made up of atoms, but it's called a formula unit. And it's called a formula unit because it's an ionic compound and it's in its lowest whole number ratio. It's the word we learned in chapter 7. And then if I had nothing but O2, O2 is two oxygens, oops, wrong color. It's two oxygens that are joined together in a covalent bond. Well, since they're covalent and not ionic, I don't use the word formula unit. We use the word molecule. So there's three different types of particles. You have atoms, you have formula units, and you have molecules. The word you pick depends upon whether it's an element, an ionic compound, or a covalent compound. Two other words here are molar mass and molar volume. The molar mass of something is the mass of one mole. And how you find that is you use the periodic table. For example, if I do the molar mass of iron from up above, the molar mass of iron, if I use my periodic table right here, is 55.85. That's not actually the mass in grams of an iron atom, but it's going to be the mass of a mole of atoms. So the molar mass of iron is 55. I'm asking my students to round it to one decimal place, 55.9 grams per mole. If you're going to do the molar mass of FeO, then what you do is you use the mass you found of the iron, and you add it to one atom of oxygen. Well, if you use your periodic table, you'll see that oxygen has a molar mass of 16. So 55.9 plus 16.0 is 71.9 grams per mole. If I do the molar mass of O2, then I just add the two oxygens together. Each oxygen was 16.0, so that's 32.0 grams per mole. I can figure out the molar mass of anything with a periodic table. Now, the molar volume is the volume of a mole. This only applies to gases. And basically, it's a known figure that 1 mole of a gas will have a volume of 22.4 liters. So you can look at that as 22.4 liters per mole, or you can look at it as, 1 mole to 22.4 liters. I can do the same thing up here. I can also take these numbers and I can flip them and put moles on top and grams on the bottom because they're equal to each other. So if we go to my second page, you'll see how this ends up getting used. My first question says, how many particles are in 3.4 moles of NaCl? Well, it's like our chapter 3 problems. We're going to start with what we know over here. So 3.4 moles of NaCl. Then we make our dimensional analysis table. On the bottom, I need to put moles in NaCl because I want to convert the units. I want to convert it to the number of particles, and I want the moles to cancel out. I also want the NaCl to cancel out. Well, I know how many particles are in a mole. I don't have to use the word particles either. If it's an ionic compound, what would be even better is to put the word formula unit, because it's formula units of NaCl would be even more specific than particles. I know that there are 6.02 times 10 to the 23rd particles, formula units in this case, in 1 mole of NaCl. Well, if I do my math, that comes out to be 2.0 times 10 to the 24th formula units of NaCl. My next question says, how many moles are in 367.5 grams of H2O? Again, I start with what I know. 367.5 grams of water, H2O. Well, same thing as before. Grams and water have to go on the bottom because I want them to cancel out. I also need to get to moles, which I know I can do. I already know that I can find the number of grams in a mole by adding the stuff up together. Well, hydrogen has a mass of 1 gram, so that's a total of 2.0. Oxygen has a total of 16.0, so, oops, I did it wrong. 1 mole of water will have a mass of 18.0 grams. At that point, I'm done. If I do my math, I will find out that that comes out to be 20.42 moles of H2O. The next one, how many liters are in 8.2 moles of N2? Start with what I know. 8.2 moles of N2. I can use the 22.4 liters thing with this because I know that N2 is a gas on the periodic table. Moles of N2 must go on the bottom. Liters of N2 can go on the top. I know that there are 22.4 liters of any gas in 1 mole, and those cancel out, and that answers my question. I've got liters. If I do the math, and we work around the announcements here, my answer is 180 liters of N2. Now my last one's a little bit harder of a problem because this time I don't just have something that goes straight to a mole. If you go back to my original paper, everything else has been going to mole, it's been related to a mole. This time I'm asking how many grams are in liters, and I don't have anything that directly connects these two things together. The only way to get to mass on my flowchart is if I go, from mass to mole to volume, or volume to mole to mass. My problem is asking you to start with liters and get to grams, so the only way to do that is for me to convert it to moles and then convert moles to mass. It's going to be very common for us to have problems that do this. I'm still going to start with what I know, and I'm still going to put my units and my substance down in the bottom, and I'm going to recognize I got to get to mole. Well, I can compare moles of O2 to liters of O2 because it's a gas. 1 mole of O2 is 22.4 liters of O2. So at this point, liters and O2 have canceled, and I'm not done. If I stop right now, I've got moles of O2, it asks for grams. So I'm going to go again. Moles of O2 will go in the bottom, grams of O2 will go on top. I know I can do that because that's finding molar mass. And I can do it like I did over on my other page earlier. Each oxygen is 16.0 grams, well there's 2 of them, so that becomes 32.0 grams per mole. Moles and oxygen cancel. I'm at my end answer, And if I put that in my calculator, I'll get 5.0 grams of O2. We'll do more problems as we go along that get bigger than this, so stay tuned for a video that conquers the more complicated problems.